They're ready.
Hello.
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 Hello, everyone.
Hey, everybody.
Oh, so many familiar faces.
Good to see you, Jiaosheng.
Oh, you look younger.
Yeah, I've lost my beard.
Yes.
Young and energetic.
Last time I didn't recognize you, Alex.
Well, I've got very little hair now.
Yes, I didn't recognize.
Yeah, that's what chemotherapy does to you.
And you look younger, yes.
Well, I'm grateful.
What about the eyebrows, Alex?
I have never shaved them in my life.
No.
Why'd you
I
shave
remember.
it?
I remember you have very, very nice beard, but it's shaved now.
Well,
But you look younger.
I'm hoping it'll. No, it's fallen out, so I'm hoping it'll come back.
Everything's okay, Dane?
Read AI knows is recording this meeting.
Recording, yeah.
I think it's
All,
read AI. I don't know what read AI. I think I decline it. There's a showing that's read.ai.
well, it needs to record for.
It's recorded now. I just as
Yeah.
I'm on the cloud. I don't like AI. I just decline. I can see it anyway.
I think it's you we need to record.
It is recording now.
Good.
Mhm.
Anyway, guys, it's recorded. Okay. Recording. Oh,
Hi, Xiaosheng. How are you?
how are you? Okay. Then somebody find me note taker. AI is recording to record this meeting. That's very strange now. That's strange. Decline. Anyway, it's recorded now, so don't worry. It will be on the cloud, and then the recording will be available on our website, both websites of SEGH and IMGA anyway.
Mhm.
Hoping that there is enough coming down the microphones that I can actually start the meeting. And to
Okay,
welcome
Gillian, you're not very loud. We can very faintly hear you. Sorry.
No. Right, I don't know what's going on. I will shout, but I don't think it's going to make any difference. I think there's a problem somewhere. Okay, I'm trying to introduce Xiaosheng and to say welcome to people from both groups, both IMGA and SEGH. It's lovely to see so many people on here. Since I can't be heard properly, I'm going to shut up and I'm going to bow out. Actually, perhaps Jane, since I am so completely unheard, if we've got questions at the end, will you actually act as chair and field it? Perfect, thank you. So without further ado, I will hand over to Xiaosheng to introduce his really interesting looking talk and say thank you, and over to you.
Okay, thank you, Gillian. Anyway, just want to let everybody know that this meeting is recorded. Okay. If you don't like recording, then you just hide yourself. I think I just begin now. Anyway, I will share my screen. Okay, can you see the screen and hear me? If yes, okay.
Yes, yes.
Great. Okay, so I will go ahead. Well, thank you everyone from both societies, IMGA and SEGH. This is a joint seminar. Well, many of you know that I have a hobby, photography. I think it's quite important to get something that everybody is interested in. So I talked to Gillian. Can I talk about photography? I think that's could be something interesting to everybody. So I'm going to talk about it. No, I just move to the next page. Now we know that photography belongs to science. I think is well. I don't want to argue that. I think most of us should agree that. But what's missing here is a definite science. When we take photos, I think we appreciate more about the arts side. We need to explore more about the science aspect. So I'm going to share my experience with you today. First, let's have a look at this one. This photo, you can see it's it's a moon photo anyway. You may see it's a photo taken, but also it's arts. The arts side is here. As the smoothing effect on the beach. Can you see that? In fact, it's caused by the long exposure. The exposure with several seconds. The purpose, in fact, was to reduce the background noise, but it produced very nice idea of tranquility. And also it has healing effects, especially during the COVID. Now let's have a look at another photo. Also, it's in Galway Bay. Okay, anyway, most of the photos are taken in Galway. I really like this photo and also like the guy who was standing there. He didn't move. In fact, this is a long exposure photo, about several seconds. And the guy wasn't moving, so it's not blurred. So the quality of this photo is very nice. Then I've noticed that he has a tripod there. So he should be a photographer. Now, another photo behind, in fact, that's the University of Galway campus. I just want to show you quite a few photos of the moon. This is Galway Bay, and this is the Cathedral of Galway, this landmark of Galway. And again, this is Galway Bay and the diving tower there. And this is the tower. And this is in the mountain area in Connemara, west of Galway. And this is Fisherman's Hut. When I post this photo, people told me the family of Titanic, who produced the Titanic, hid there for several months after the accident. So when you post some people will tell you the story behind it. Normally, you won't be able to find those stories in any textbooks or in any books. And this is the Lime Pine Island in Galway. In fact, they're also taken during the COVID. When I took the photo with my wife there, and my colleague was singing Irish music in the radio. So you can imagine it was really nice. And this is behind is the University of Galway. And this is small mountain, 3 students there. And when they left, I found a cat there. And this is moonrise. And I tried to put this one, the moon, over the Cathedral of Galway. Anyway, we can just use a zoom lens, of course. But here, the first science question comes. Color. Okay. When you listen to my talk, I will keep asking you questions. So what is the color of the moon at moonrise? In fact, I only knew the color when I was in Ireland. In fact, normally I think people just know it's black and white. Perhaps you could be wrong, because moonrise is not really black and white. And also, same questions applies to the sun. Sunset, sunrise. So when I ask AI, it tells me, different colors. And so from red and then orange, yellow. So the reason is because of a scatter effect. Scatters shorter wavelengths. The air scatters shorter wavelengths more. And then longer wavelengths can travel to our eyes. So with the increase of the height of the moon, the color will become yellow and then white. Now I keep asking the question, why do the longer wavelengths pass through more easily? Because of relief scattering. And it's a physics process. Light interacts with particles much smaller than its wavelength. There's a proportion. It's an inverse proportion to its wavelength. In fact, I tried to find the function of Rayleigh scattering. It's very complicated. Anyway, we understand the reason why, okay, because of scattering. Another question, why is the sky blue? It also applies to Rayleigh scattering. I leave this question to you. Now, let's move on to the moon photos. This is the clearest photo I've ever taken because it was very bright that night. And then moves a little bit up, and then moonrise over the ocean, the sea, and link it with culture. And in fact, another culture event in Galway. You can see the cathedral is behind. And Christmas, this is in the coastal area in Galway. It's there every year, every Christmas. This photo makes many Americans, okay, many Irish abroad homesick, okay. And there's a song called Watch the Moon Rise Over Claddagh. So this is the boat and moonrise there. And in fact, this is the Claddagh area. Again, this is University of Galway. Clock Tower of University of Galway. IT building of University of Galway. And this is the best moon photos I've ever taken. It was during the COVID. And the story behind it that I think one of the owners may have already died because their family told me their father could die anytime. Anyway, then I sent all the photos to them. So quite a few photos were taken there. And you can see quite a lot of people there. And some people there. And this is Galway. This is Salt Hill area. And I tried to put it over the tower. And again, another one, I think it was taken this year. And then I tried to put the photo on the tower here, the diving tower. It's not easy. It happens twice a year. And you know the weather in Galway. Quite often it's rainy or cloudy. Finally, I got one, but not so clear. Then I decided to go back the next morning from another direction. Got it. And this is the tower building of University of Galway. And this is the mountain area called Connemara in Galway. Do you know where it is? This is Prague. When I was attending a conference there, I found it was full moon, and then I was thinking, where can I take a nice photo? So I planned there and went there. Okay. Moon photography. I think many people are trying to take very big and clear moon photos. It's very hard if you just use ordinary camera, okay? If you have very powerful telescope, that's fine. I think for moon photography, mainly we want to show the ideas. It needs to be meaningful. You want to show beauty, tranquility, or show landmark, or link it with events or culture, and also show your creativity. Now, equipment, I had a Canon for most of the photos, and then now I have a Nikon Z9. You need various size of lens, okay? And I don't have very long lens, but I have magnifiers. Most importantly, for moon photo, you need a tripod. I have to acknowledge that I don't use software very much. I just save the files in RAW format and then convert it to JPEG and then use Snapseed. My tips for moon photography is get a phone of yourself, of your own, and be well planned. How do you plan it? You need to think about moonrise, moonset time, direction, weather, and wind or tide, etc. I want to recommend one app for you, mooncalc.org. If you go to the website now, so you can see where the moon is now, and anyway, on the left side, you can see all the parameters. And also you can change the date and time. You will see which direction it is. So it's very good for planning. Just this website, mooncalc.org. And then I can zoom into Galway, then you will know where the moon is now. It has a mobile phone app called mooncalc.org. Then you can plan your moon photography. You will know when it's a full moon, which direction it is. It's a very good tool for you to plan your moon photography. And it's free. Now, how do we reduce the background noise? I think many people taking moon photos are annoyed by the background noise. So the answer is very simple, just keep ISO low, okay? It's very important when the background is dark. And then how do we keep it low? Just increase the exposure time. But on the other hand, you cannot increase too much because the moon is moving. So it's always a balance between your speed and aperture and ISO. Another question, I think quite a few people get a blank disk of the moon. If you want to get a texture, then my advice is that when it's not too dark, you can take the photo. If you have any questions, you can just write it there, okay? Write in the question box. I cannot see it now, but I will answer your questions after the talk. Now I have a question for you. What is the shape of the moon? It's a scientific question. Well, looks stupid, but I want to show you. Very interesting there. So that's the parameter. If I increase the exposure time, what can you see? So you can see that the moon is it's really round, okay? It's not what you saw. So if you change the parameters, you have a full picture of the moon. So if we go back to the question, in fact, that's the question I want to ask my students to think about scientific observation. Is it reliable? Are our eyes reliable? You know, and also when we monitor something in environment or in our medical geology or environmental health, geochemistry, or whatever, so one off monitoring and one on long-term monitoring, which one you should consider? And also, how do you design your experiment? You just want to get what you want, then you have to really think about academic integrity issue. Okay, anyway, that's the talk about the moon. I think I will move to the next one. This is very hard. Aurora. I just want to warn you, the science behind aurora is very, very hard. I will try to explain to you. Now, perhaps you get a lot of people talking about aurora, and also you see a lot of media interest in aurora recently. The main reason is that the sun remains active. I will explain it. In fact, before the peak time in 2023, I provided some photos. Not so good, but anyway, at least we got aurora here in Ireland and also in Galway. So I provided to RT News, this news TV of Ireland. Anyway, the sun remains active. What does it mean? It's related to solar cycle. It's the change of sunspots. The guy, Johann Rudolf Wolf, calculated this solar cycle. And the reliable sunspots can start from 1755. So starting from 1755 until now, we are in the cycle 25th. So we are at the 25th cycle now. And how about this cycle looks like? In 2019, a group of experts predicted, and then gradually we found that it's far away from reality. So it's hard to predict it. And then on December 19th, re-predicted, and then that's the new prediction and shows the peak earlier and stronger. On October 15th, 2024, both NASA and NOAA declared solar has reached its maximum. So why is there a solar cycle? That's the question I want to ask, because I want to understand why are we so interested in aurora? It's very much related to the magnetic field of the sun. It keeps changing. And it flips its polarity every 11 years. So this change, very strong change, also causes the change of sunspots, solar flare, and coronal mass ejection, which are very much related to aurora. The change of a magnetic field causes the change of sunspots, then cause the change of solar flare and cause aurora. Now I want to show you quite a few aurora photos here in Galway. So where can we get photos of our aurora in Galway? First, you need to find a dark place. The place that's close to Galway is the wind farm. So when there's aurora, I just drive to wind farm. It takes about half an hour drive there. And I will show you quite a few photos here. And also wind farm, and the road. This is the lake called Aurora. It's about half an hour drive from Galway again. And this is a small lake in the mountain area in Galway. Another photo. In fact, that's the moon. Another photo. And the road. And Loch Corrib, Aurora again. Luckily, there was a boat there. Another guy was taking photo there too when I was there. And the mountain areas of Galway. I really want to take good photos. I never saw any aurora photos here in the Pine Island of Galway. Anyway, it takes about 1 hour and a quarter there from Galway to this site called Pine Island or Derryclare Loch. I never saw such a photo, but I believe there should be aurora there. So I try to take photos there. And then another day.
Cut from.
Okay, now another night. I really like that one. It's just paradise. I was there alone. I was just enjoy the paradise there myself. And then the moon was on the right side. And the moon came out. I stayed there for I think, 2 hours. Just enjoy the scenery myself. And then we get the halo of the moon. Now, really, the best one so far. May 10th, 2024. It reached the maximum level of aurora called KP9 or G5. That was the strongest. And we were well prepared. Then I took my students there and then we really enjoyed that night. I want to let you know the direction is in the northeast direction. In fact, it's fairly east direction. We were planning the northern side, but in fact, it was everywhere. I will explain why it was everywhere, all the directions at that night. Because when we call northern lights, normally they're north, but if it's very strong, it can be any direction if you are at the certain altitude. Now, if you look up to the sky, and when I left there, I took some photos there. I thought I could take this photo in Iceland only, but in fact, I got in Galway, just a few kilometers away from that side. I decided to go there and then got it. In fact, this direction is the west, okay, very west direction. It's not north. And this is a road, very nice that night. And then I decided to go there, Fisherman's Hut. You saw a photo there just now. And Fisherman's Hut. And a little tree there. No, another night. October 10th, the second strongest aurora show in this cycle. Well, I don't know this cycle, I know at least during recent years, second one. It reached the, I think at some stage reached the 9, but most is 8 kp value. This is the tourist center of Cliffs Moher. Cliffs Moher is one of the tourist attractions in Ireland. And this is Cliffs Moher, the tower. And then there's Atlantic Ocean. In fact, we can see the curtain around us. I like this photo very much. And again, it's Cliffs of Moher from another angle anyway. Normally, tourists won't walk that far. If you keep walking, you can see it. And again, this is to the mountainside of Cliffs of Moher. This is Cliffs of Moher to the southern direction, south direction. So not so strong because it was KP8, not KP9. But you can still see the aurora there. And then we went to another tower, not far away. Now, when I sent, well, again, I took my students there, and then when I sent them back to Galway, because we got a lot of clouds. Then when I went home, I found, my God, it's clear again. This is very close to University of Galway, about 2 kilometers away from my office. And it's very dark. This is one of the best aurora photos I've ever taken. And again, I was there alone, but you can see, when you go there, you will try to understand the story of that castle. It's called Menlo Castle. And then I decided to go to the beach area, and then after that, it was too bright. Anyway, I got it. Last year, I didn't take too many aurora photos, but I tried to challenge the urban lights. So we still got it. This is the long walk in Galway. And this year, I decided to challenge it again, challenge the urban lights. And we get also a few visiting scholars with me, and I took them there. You can see this the long walk of Galway city. So we can get aurora over the city, okay, when it's strong enough. And this is Clada area. Another one. This is the tower. And this is Salt Hill, a very popular area in summer especially, full of tourists all the year round. And then I decided to go to somewhere dark, so went to a lake, and then I got it. I tried to find some boats. Anyway, I found 2 of them there. I went to the pier again, and I found there's no boats, unfortunately, but I found a table. another one. And there was a fog with both fog and aurora, just like paradise, if you can imagine that. And this year, March 20th, then we get another one just 1 month ago. Anyway, if you go somewhere dark, you should get better pictures. But this is just on the beach of Galway. It's called Silver Strand Beach. Okay, can we predict aurora? That's the most challenging question. Yes, the answer, but sometimes we may fail. I want to warn that be careful of the media. Quite often they exaggerate it. So we really need to understand how we predict it. I will explain to you. Perhaps you will keep asking those questions, the challenging aspect of predicting aurora and also most frustrating part of aurora hunting. I leave those questions to you. I will try to provide you some background of the science. Let's start from the concepts. Aurora. It's a natural light display. Well, people may argue it's not natural. Anyway, I don't really want to fall into those arguments. It's natural. It occurs when charged particles from the sun collide with atoms and molecules of the Earth's atmosphere. Okay, we normally call aurora borealis. Okay, aurora borealis, whatever. We normally mention about northern lights. In fact, if you go to Australia, go to New Zealand, you can also get southern lights. They're quite equivalent. Okay. Now, charged particles. I try to find what causes aurora. Then this one shows charged particles hit the atmosphere, atoms and molecules excited, and then when they cool down, then they give out their lights. But I found they use the word electrons. It's not charged particles. They're very different. Then that caused my curiosity. What are the charged particles? So I asked AI chemical symbols of the charged particles from the sun. So that's the answer from Copilot anyway. So you can see there are many particles. Electrons are the majority. In fact, they're very small anyway. And also we have protons and alpha particles, and also many other particles. But electrons should be the most one that cause aurora. And then how about protons? Protons can also cause aurora, but they're less visible. Then I try to understand the process. Then I found this one. This is very nice. The diagram shows the process very clearly. Solar eruption. Then you will get solar wind. Then it goes to the Earth, interact with the magnetic field of the Earth, and then it will cause aurora. There are quite a lot of the jargons anyway, if you really want to understand. So I want to ask you, if you are interested in it, go to this website, spaceweather.gov or spaceweather.wnoaa.gov. Anyway, this is a new website. It's the same, I think there's a mirror website of Space Weather Prediction Center. Aurora, you can see these electrons collide with molecules and atoms. And when they come out from the Earth, the sun, it's called a solar wind, and it interacts with the magnetic field of the Earth. And the interaction causes geomagnetic activity or geomagnetic storms. And the magnetic field of the solar storm is called interplanetary magnetic field. When its magnetic field direction turns southward, we will get stronger aurora. Too many jargons here. There are two types of solar events that cause mainly aurora. One is called CME. We use this one very often. We are going to talk more about it. Another one is corona hole. It's the low density on the corona of the sun. It's not really open, but people always use the word open because it goes vertical, the direction of the magnetic direction. Okay, that causes the corona emits from the sun more easily, then we'll get stronger, quicker solar wind. Then that will cause aurora. If you go to the website now, there is an alert tonight and tomorrow morning, just tonight, okay, there could be aurora caused by corona hole, not CME, not corona mass ejection. Anyway, there are too many jargons. If you're interested in it, go to Space Weather Glossary. Go to that one, go to this website, okay. And there are quite a lot of jargons there. I'll leave that to you. Another one, you can find a lot of explanation directly related to aurora. There are a lot of jargons here. They're explaining those jargons there. Now, go back to the question, how do we predict aurora? Now, when we talk about prediction, I think the first question is the time scale. Which year, which month, which week, which day, which hour? You know, we get it. I think we are really talking about time scale. In this case, I was trying to find somewhere you can, you know, for the answer. Luckily, I found here. Forecasting aurora on different time scales. Well, that's exactly what I'm looking for. It may not be so easy for you to understand it. Go to this website and then you should find it. Okay, I will try to explain to you. First, prediction aurora in years. It's related to solar cycle. We explained earlier, 11-year cycle, right? Caused by the change of magnetic field of the sun. Then we may get, you know, solar maximum. You get lots of sunspots. We may get solar minimum. We just pass the solar maximum anyway. And then solar minimum, we get less, you know, sunspots, but we still get some, we can still get some aurora, but may not be so strong. So it's related to this one, sunspots number. So this is the peak here. So you can see we have more or less past the maximum now. Again, that's the number of flares that may cause aurora, okay, may or may not. That's another question I'm going to explain to you. Anyway, we have passed the maximum. Again, the prediction, this is the most recent prediction, so it goes down. Many people say this year we are going to still get a lot of aurora, but I believe in science. Okay, it is going down. If you go to the whole series, you know, from 1975, you know, we are at the 25th cycle. So 25th cycle is not the strongest. If you go back, you can see they are much, much stronger in the past. Now, that's the year prediction. Okay, we are going down from the top now, maximum. Now, prediction in 27 years or around 1 month. Another way we can predict. This is related to the sun rotation. The sun is rotating. That's interesting, right? If we get magnetic activity about 20 years, 7 days ago, we may get it today or minus plus 2 days. Does the sun rotate? Well, I'm trying to learn, okay? Okay, get this information here. In fact, it rotates and also at different speed, at different latitude. And that's very longitude. Anyway, that's very interesting there. So on average, 27 days or 28 days. So quite often we see 27 days or 28 days as average, you can see. One of the evidence is the sunspots. So if you can see that sunspots keeps rotating. One of the interesting things for us to predict aurora is to chase the rotation of sunspots. If we get a large sunspot area, you know, it's about 27 days, right? It's facing us at least for about 2 weeks. So it's facing us, you know, directly, then we get a higher chance of getting, you know, any eruption will face the Earth. We get a higher chance. So it's one of the longer term months scale prediction is to chase the sunspots region. Anyway, I try to ask the AI again, how do we know it's rotating? One of the methods is called sunspots. Anyway, there are so many others, and that goes beyond my knowledge. Anyway, at least we can see that the sunspot is rotating. Now, this is the most important, hours to days prediction. That's really we want. But unfortunately, it's very challenging. And also we get lots of uncertainties. As related to CME, that's the ejection from solar flare. Okay, luckily we get a lot of sensors. So I'm going to explain to you. Go back to this process. Quite a lot of questions we need to answer. First, is there a solar flare? Well, it doesn't happen all the time, okay. Sometimes we may have that solar flare. And does this solar flare produce CME, corona mass ejection? Does the CME fly towards the Earth? It's so far away. And then the magnetic field, does it, the direction does it face south? So because there are 4 questions here. In fact, we have to answer yes to all the 4 questions to get aurora. So that's why quite often when we get a solar flare, very strong for solar flare, you may get it in the news, then people may see, well, aurora or whatever. You can see 4 questions there. First, solar flare is monitored by SDO, Solar Dynamic Observatory. It's 36 kilometers above. And also we see those pictures anyway, it's monitored by SDO. Another one is quite often used now, it's called GOES, Geostationary Operational Environmental Satellite. This is the image that's provided by this one. So we can monitor solar flare. This is some statistics starting from 1996, got a very strong one in 2003. Unfortunately, this year we haven't really got a double-digit flare yet. One of the one we got in, I think in February is 8.11. And then CME can be imaged by the LASCO instrument on SEGH mission. Those are the images. When we get a series of images, then we will see it. So that's the that's CME. This one goes to the north of the sun. We won't get it, unfortunately, even though it got very strong there. It doesn't go to the Earth. And this one, you can see we get circled here. So it's flies, some part of it's flying towards the Earth. In this case, we are going to more or less, we will get aurora in this case. And then the CME characteristics are calculated by Cactus software. When it's calculated, we will know this direct duration, angle, and then velocity. When the velocity is 1000 km per second, it takes 41.67 hours to arrive at the Earth. Anyway, you can calculate it, okay. The distance, we know the distance between the sun and the Earth. And then we know the speed. You can know how many seconds it will take. This year we got one. In fact, this one we didn't miss it, and we got G4 aurora. That's why we got a lot of. In January, in fact, just took just 1 day to reach us, so we got it. In fact, we got quite a lot of X flares, very strong flares. This in early February. I was very excited, but unfortunately, we didn't get a lot of CME. So even though we get strong flare, we may not get aurora. When there's aurora, or even when there's a flare, there could be news alerts. In fact, I just copied this morning. So there's our alert G2 geomagnetic storm watch for tonight and tomorrow morning. If you go to the website now, you should see it now. And if you go to 3-day forecast, go to products and data, you get 3-day forecast. So that's tonight and tomorrow morning. Just pay attention. There could be errors and uncertainties because it's calculated based on a series of images. Okay, calculated by the software. And when there's alert, I normally go to this website called Space Weather Live. When you go to the website, you keep checking KP values, solar speed, and pay very much attention to the direction. BZ, XYZ, that's the magnetic vertical direction. It should go to south. Then I will explain to you why we need to go to south anyway. So when the CME arrives, we'll jump, okay? Speed and magnetic field, they will jump, and density. Now, the Earth has our magnetic field towards the north. So the direction of the magnetic field from CME should interact with it. Then you get strong aurora. That's why it should go to south. If it goes to north, you get weak aurora. But if you go to the south, you get strong one. Anyway, it's too technical. For ordinary people, you can have a look at the ovation called aurora ovation. That's the over. Okay, this is Ireland. So anyway, it's to be north of Ireland. We might see it or get it because it's above in the sky. So I will talk a little bit about this one, ovation or forecast. It's based on Discover spacecraft, Deep Space Climate Observatory. It's located at the I-1 location where the gravity from the Earth and the Sun are equal. Then it can stay there very stable. This is the location of I-1. It is 1.5 million kilometers away from the Earth. If the aurora speed is 500 kilometers per second, so we divide it by that, we get 3,000 seconds. Then we get 15 minutes. Normally it will be faster than 500 when we get CME. So we will get a quite precise prediction in about half an hour, or a little bit more or less. In this case, it's quite accurate because it's monitored actual solar wind. So if you want to see the product there, go to this website, 30 minutes forecast. So I explained to you why it costs 30 minutes, because about 30 minutes based on the speed to arrive at the Earth. We know, unfortunately, we can only know very certain about half an hour earlier. And then when there is a flare with CME, there will be news alert, okay? And also another one I want to recommend to you is Space Weather Live. It has app, then it can give you alert, you know. Download this one called Space Weather Live. Again, when the aurora comes, you can see it takes about half an hour, or this one a little bit more than half an hour. So that's detected, and this is the Earth. So when you go to the Space Weather Live, you will see it. In fact, I just explained 15 to 45 minutes aurora forecast. Okay, just explained to you now. It's accurate and short-term aurora forecast. Now questions, another one, very important concept, KP value. In fact, it's average value. It shows how strong it is. KP values, KP9 is equivalent to the NOAA scale G5, okay. The highest one occurs only 4 per cycle. Per cycle, 11 years. So we only get 4 on average, 4 times every 11 years. very rare. And KP value. So I want to explain you why in Ireland, at that night, we can get aurora in every direction. So you can keep in mind, here is Ireland. On top of Ireland, so here in Ireland, we can see it in every direction. And there's a height, okay, of aurora 80 kilometers to, well, 640 kilometers above the ground. So that's why if it's not overhead, but you can still see it in the north direction. Now, another question is the color. Really interesting, we need to understand the color. Well, that's why we explore the science behind it. The heat, oxygen and nitrogen, you will get different colors. I try to find a good answer to this question. Luckily, this one explains very well. Science, NOAA.gov. Electrons, heat, oxygen atoms, you get red color. Heat, nitrogen atoms get blue. A secondary electron, in fact, produced by reduced energy, then you get here when you hit the atom of oxygen, get blue color. Then when electron hits nitrogen molecules, you get purple color. So the colors are related to different states. When you hit, you will get different states: oxygen S1 state, D1 state, nitrogen P2 state. Then they will have different energy. S1 green, D1 red, and different energy, they have different height. Then this one is high, low, this one is high. And then why do they exist at different heights? It's related to their different lifetime. D1 has long lifetime. They can only survive at the high level, higher elevation, because they can easily be deactivated before they release the energy to get the color. And this one shorter, so it's lower. And then nitrogen get immediate release. Anyway, too scientific. Okay. I tried to get a good table. Finally, I have reached this level. So summary for aurora prediction: in years, it's related to solar cycle. We can get the overall trend. 27 or 28 days or 1 month, overall trend. It's related to solar rotation. The sun is rotating, okay? And then hours to days is related to CME or corona hole we just mentioned, but mostly we get stronger ones from CME. Then there are quite a lot of questions we need to answer yes, right? And then very short term, half an hour prediction is related to CME and is monitored by Discover at I1 location 1.5 million kilometers away. This is accurate. Okay, how do we take photos of aurora? Night photography, okay, get your large aperture and get longer exposure. And some questions, why it's not so colorful when I see it? Camera does a better job. Is there a controversy regarding post-processing? Quite a lot of beginners, they process their photos too much. My advice is don't go too far when you enhance the photo. Don't go too far. Should I monitor space weather live all the time? I think the app provides you the notification, and also you can join some groups to share the information, or let other people to remind you. I kick those two questions back to you. Most challenging aspect of a prediction of aurora, and most frustrating part of aurora hunting. Now, I just want to let you know my photos are free. And also including commercial use is free. If you go to this website, universityofgalway.ie/INE/gallery, then you will see this one. You get Google Drive link, but I cannot update anymore because of the limit of the size. Google Drive free storage, I think, is 15 gigabytes. And they have very large space in the OneDrive of my university. So if you click this one, you get all the photos. You get aurora photos 3 times anyway there. I got a China photo. I think it's Jiuzhaigou National Park there. And then many other photos there. Now, photography, we need interest and curiosity anyway. It's developed by creativity. Just get different perspective. Supported by science and technology. I talk it a little bit. You can see it's very much related to geography and also related to physics. Technology, I think, is hardware and software. It's related, supported by it. And of course, try to get a beautiful photo and try to make your photos useful for the society. Then you get recognition. It's my understanding of the art of human body. Now, practical tips. For moon photography, get this one, mooncalc.org, both website and app. Aurora prediction, go to spaceweather.com or Spaceweather Live, both website and app. Take-home messages, right place at the right time. They just want to let you know, seldom by chance, okay? It's always well planned, strong science behind it. The message I want to give you is that photography is more than photo taking. Photography is a journey into curiosity and creativity. I'm finished. Thank you.
Thank you very much, Xiaosheng. That was amazing. I think we should just show our online appreciation. So either clap in your own room or put the clap screen on. Thank you, Xiaosheng.
Thank you.
And again for sharing your photos, your experiences, but also the fact that you enable us to access these photographs for free. That's amazing. And I would just say, from a personal perspective, you've made me quite excited now because I'm off to Kielder Observatory tonight to see the dark skies. And I have to say, I'm downloading Space Weather app on the way. So
tonight.
Tonight, I know you made me even more excited than I was before. So we have a few minutes for questions. There are some in the chat, Xiaosheng, and if anybody would like to ask a question live, if you put your hand up, we will come to you. So we'll take any live ones first, while Xiaosheng has a moment to look at the chat.
Okay, just the first one, I think it's AI. I think I declined the AI anyway. I don't know what's AI there. If somebody registered, they can get AI. Okay, that's about AI. Gorgeous photos. Okay, yeah, and website. This is screen. Anyway, okay. Look at the view. Any questions there? Let's go some great ones.
I think Gillian has a question that says, do you have any photos of Steve's?
Okay. Okay. Yeah, I got it there now. Yeah. Well, Gillian, it seems that you are a fan of Aurora. You are Aurora hunter. Good to know. I'm glad. So I'm not alone. I think we got a little bit. You can see the one. I think the one I got from Salt Hill, Ireland, in just a few. I think it's January 19th. That one we get a Steve there. Vertical one, we saw it there. Yeah, we got one there. In fact, I have to acknowledge I didn't really know Steve a few years ago. I saw it. It's just so quiet. I thought it's white clouds. But you can see we keep learning. And I missed it, unfortunately. I didn't take it, you know. I thought it's just clouds. Unfortunate when I for the first time when I saw it. So you can see, in fact, I try to get those deep now, and also, in Cliff's Moor, I also got some Steve, not so strong, but I did get it. Well, that's very interesting. Yeah, thank you, Gillian. Good. Okay, another question is, what is the difference between a solar flare and a CME? Oh, they're total different concepts. Solar flare, if you go, it's just a burst of, you know, of the corona. It's just a burst. It's an event, I would like to say. CME is a material. It's the material in the solar wind. They are moving. It's corona mass ejection. In fact, that's the materials. There's you know, it's called plasma. Some people call it, or those are the ions I showed you. There's Ask AI to show all the ions there. Most of them you get electrons and protons. Most of them, that's the most components there. Okay. Flares, a burst. Oh, thank you for answering that. You know. Okay. Some also. Okay, thank you. Let me see. Are there any other questions? I'm trying to find a question. Thank you.
There's lots of thank yous, I think, Xiaosheng. I don't see questions.
Okay, anyway, yeah.
Thanks for the heads up for the Lyra meteor shower and comet as well tonight. You're joining me at the dark skies. So I'm just having a look. Are there any final questions for Xiaosheng? Gillian would like to ask a question. You might have to type it, Gillian.
If you speak loud.
It's on there. I'm scrolling. Gillian said, she said, that was a fabulous talk. Thank you. No. Up, yep. Keep going up. For those in UK Aurora Watch, UK is a useful alert site.
It was, I've got some really good ones from October, the whatever it was that I put in there.
October 2024?
Yes, what was so good about that date?
Yeah, that was a wonderful date. That was the second strongest in this cycle. Well, I don't know the cycle. In second strongest, you know, both in 2024. The strongest was May 10th.
So I think Gillian asked, what was so good about that night? Was it the strength of the cycles? Is that, Gillian, you're asking about what made 2024 so good?
Yeah, it was. You can see it was the peak. In the end of last year, then, well, some people say this year is still good. I don't believe that. You can see the trend. You can see the prediction.
Okay. Well, we're on the hour, so thank you very much for everyone who's attended as well, but particularly for Xiaosheng for just some amazing pictures and sharing his experiences and knowledge and stories behind some of those images. So thank you very much. Thank you, everybody.
Thank you, everybody. Thank you.
Good to see some familiar faces. Thank you.
Ciao.
Bye.
Thank you.
Hello?
Hello, Alex. I can hear you.
No.
Alex, do you want to say something?
Aye, I'll switch off.
Okay, that's fine. We just finished now. We're finished.